Welcome to McMaster University's COMPSCI 1MD3 course, Introduction to Programming. Over the next 12 tutorials, we'll go through a basic crash course on how to code with Python. If at any point you need any assistance at all, please reach out on the Piazza page, at my email, or in the YouTube comments section, and I'll try my best to help you along. Now without further ado, let's get started. To ensure everyone is on the same page, let's spend a few minutes going over the syllabus for COMPSCI 1MD3. The instructor for this course is Dr. Moore, and his email is available right here, along with the emails of all the other course TAs, including myself. All of the assignments, midterms, and final exam will be submitted on JupyterHub, of which our link is available right here. I'll talk more about how to access JupyterHub later on in the video. Now, if you have any questions at all about the course, you are more than welcome to email me or any of the other COMPSCI 1MD3 TAs. However, I would recommend instead of posting your question on the Piazza page in order to get a quicker response. There is a dedicated TA whose job it is just to look at all of the Piazza questions and answer them accordingly. Once again, you're more than welcome to email me. However, in all honesty, if you do email me a question, there's a good chance I will double check with the Piazza TA to ensure that our answers are in sync, so you can short circuit the process and speed up your response time by asking on Piazza directly. Now, if we scroll down to the assessments table, you can see that a significant portion of the course mark is based upon the assignments. The assignments are released every week. There are 6 in total, and they are released on Monday and due every Sunday at midnight. These assignments are not marked manually by a TA, they are auto-graded. They are graded by software. The TAs are not involved at all with the initial grading process. So with that in mind, please make sure to ensure your code has the correct output for every single question, because that's what that's how the auto-grader works, is by looking at the output for a specific segment of code and ensuring it matches the right output. Now you'll notice with the assignments and other assessments table that there is no mark for tutorial. There is no in-class quiz, there's no participation or attendance mark for these tutorials. These tutorials are optional, not mandatory. They're meant to supplement your understanding of the course content. So I totally understand you find these tutorials to not be helpful in your success for COMPSCI 1MD3. However, I still highly recommend, even though it's not mandatory, to watch all of the tutorials and do all of the in-tutorial coding exercises. From what I remember, last semester, almost all the students went to tutorial up until the first midterm. And then because they went to tutorial and the midterm was relatively easy, they really crushed it and did well for that midterm. And then they stopped going to tutorial, which I totally understand. I'm a student too. However, unfortunately, those students really didn't do well on the second midterm because they hadn't gone to tutorial and practiced accordingly. Fortunately, those same students came back, well, most of them, and they did quite well for the final midterm and final exam. So I really recommend actually doing the coding exercises you see in these online videos. Coding is such a big, broad topic that if you're not watching the tutorials and doing the same exercises, you might not be studying the right material for the tests. So please, even though it's not mandatory, watch these videos fully, and whatever coding exercise I do on my screen, please replicate on your own computer. Now the last thing that I want to talk about is academic integrity. All of the code that you submit in this class will be automatically analyzed by our code checking software, and if your code is found to be similar to another student's code, it will automatically be flagged and you will be penalized accordingly. So please do not copy and share code amongst yourselves in this class. you will be caught by the software, unfortunately, and it's really not worth it. A lot of students were caught last semester, and it didn't go well for them. So please, if you need help with any questions at all, ask the TAs, ask for help. But if you copy code, it's not going to have a good result. So thank you for your understanding. Awesome. Now, COMPSCI 1MD3 is a course on my favorite coding language, and that's Python. Now, Python does not come by default installed with Windows, which is what I'll be using for the duration of this course. So I'll try to install Python very quickly on my computer. Now, in order to install Python, I'm going to open up a new tab, and I'm going to head over to python.org/downloads. And at this link, I can grab an installer for Python. Now, this number next to the word Python indicates the Python version that you'll be installing. For this class, you can use any Python version that begins with the number 3. So all of these versions are acceptable, but you cannot use Python 2.7 for this course. You must use Python 3. So I'm going to install the latest version, which is Python 3.8.2, which is the most latest stable version, and it's fairly simple to install. I just download, and then I run the installer, and I'm going to add Python 3 to path. You don't have to, but this makes it easier generally for some of the stuff that we're going to be doing. And I'm also going to install pip, which is a useful tool we'll talk about later in terms of installing additional libraries. And I just run through the installer. It's quite easy. And in just a few moments, we'll have Python ready and set up. And so I'm choosing the default installation. There is no reason to do a custom installation, but of course you're welcome to if you like. And my apologies for my computer being slow. I spent my TA money buying a new laptop, but it has not arrived yet, so for the first few tutorials, you'll have to bear with my slow computer. My apologies. I also don't have Wi-Fi right now, so I'm running this off my cell phone's data connection, so you can understand, I hope, the slow internet speeds. And so with the default installation, it comes with the idle development environment, and it comes with pip, which are both useful things that we'll be using for the duration of the course. It also comes with the docs, but that's not as useful. But, I'm sure a lot of hard work went into it. Almost there. It's installing Bootstrap too. Okay, that's cool. I guess we can make some fancy websites then. Bootstrap is a template for making modern, quote-unquote modern, and responsive website designs. So if you're looking to make a portfolio website, Bootstrap is a really useful tool. I used a lot of Bootstrap on my website. That's a swallow.me if you want to check it out. A shoddily made website. But there was a lot of Bootstrap in it, a lot of Bootsnip. This is a really old laptop, as you can probably tell, which is why a lot of things take time with it. Next week we should have a much faster laptop, hopefully. Hopeful. Awesome. When you write code, you generally write code in something called an Integrated Development Environment, or IDE. Now, our Python installation came with something called IDLE. Now, IDLE, which stands for Integrated Development Language Environment, I'm pretty sure. I'm not too sure if that's what the acronym stands for, but it's an IDE, and it lets us write code very easily for Python. Now, for this course, I'll be using IDLE to write all of the code. However, you're more than welcome to use another fancier IDE if you want to. It's all the same. So to open up the IDLE program, I just type IDLE into the search box, and I can open it up. And there we go. And I've made the font very big so that it's easy for you to read on your computer. And I'm now going to make a new Python program, and I can do that by hitting File, and then New File. And I can save this program accordingly, so I'm going to hit Control S to save, or you can also go to File and Save As. And I'm going to save my program in just any spot in your directory will work. I'm going to save it in a specific folder for this course. And I'll save the program as, I don't know, let's say first_program. The file location and file name does not matter. It will matter later on when we do database stuff, but for now, where you save the file is irrelevant. Cool. And so on my left-hand side, I have my Python program, first_program, and on my right-hand side, I have my Python shell. So I'm going to write my code in this window, and when I run the code, the output is going to show up in the Python shell. So I'm writing code here, and the output comes here. Perfect. Now let's make our first Python program. And for our first Python program, we want to do something relatively basic. We want to output data to our Python shell. So to output or print out data to our Python shell, we're going to use the print function. So I'm going to type print followed by 2 brackets. And whatever I put between these 2 brackets of the print function will show up in the Python shell. And if you don't believe me, we can test out this code right now. So for example, I can print out the number 2020, and now 2020 is going to show up on the right-hand side. So if you don't believe me, we can run our code to make sure. So to run our code, you just hit the Run tab and scroll down to Run Module. And then we have to save our code every time before we run. And now it's going to output 2020 in our right Python shell window. And of course, you don't just have to output 2020. I could output another number, like 2010. And as you can see with the asterisk, our code needs to be saved again before we run. And now we output 2010. So it's relatively simple. So at this point, please make sure to have IDLE opened up on your computer, have a new Python program made, and make sure that your program is able to output numbers as you see fit with the print function. So I'm going to pause for a moment, and please make sure you're able to replicate this on your computer. What did I have to do to get this done? Well, I had to open up IDLE, and I did that by searching for IDLE, and then clicking on it. And then once I had IDLE open, I had to make a new program, and then I had to write print 2010 in my new program. And of course, if any of this is not familiar to you, you can go back in the video and play it again. Although please keep in mind that because this might be your first lesson, it's totally okay if anything goes over your head. It'll become much easier to understand this not by watching someone else do something in a video, but by practicing yourself. So, and of course, if you still don't understand what's happening after practicing, you're more than welcome to email me or any of the other TAs or ask on the Piazza page. Cool. Okay, now, in order to print out a number, I don't need to pass that number directly in the function between these brackets. I don't have to write the number directly in here. Instead, I can use something called a variable. So, a variable is just when you give a name for a specific piece of data. So, for example, I can initialize a variable by writing a variable of some name, let's say num, and then I can say num is equal to 2010. And now instead of passing 2010 in the print function, I can pass num. Right? So what this code has done is I've told Python that the word num is equal, it's a placeholder for 2010. And now wherever Python sees num in our code, it's going to replace it with this equivalent value. Beautiful. And now if I run this code, it will still print out 2010 because it was the same as the previous code that we have. Now, a variable is mutable, which means we can change the value. So for example, I can initially have it set to 2010, but then I can redeclare the variable to have a different value, let's say 2020. And now if I print out the same variable, it'll print out two different values. Okay, so take a moment and try to replicate this with your code. Not too shabby, right? And really the best way you learn how to code is just by playing around with the coding software, playing around with functions to understand how they work. Now, there are a few rules with naming variables in Python, and I believe they're scrolling on the screen right now. But you can give a variable pretty much any name as long as it follows the listed rules. So for example, a variable name can't begin with a number. So if I wanted to name a variable for num equal to 2010, I would get an error. And it says this is invalid syntax because it breaks one of the Python variable naming rules that I put up. Cool. Now let's suppose instead of printing out a number, I wanted to print out a word. Like what if I wanted to print out hello? So in order to print out hello, could I just pass that inside of the brackets? Would this work? What do you guys think? Do you guys think if I just wrote print and then put hello between the brackets, that would work? Well, the great thing about code is we can test our ideas out. Nothing's going to break. If I run this code, my computer's not going to explode. You can see what happens. And it says hello is not defined. Why did we get that error? So when Python sees a word that's not a keyword, it assumes that's a variable name. It doesn't know that it's meant to be an actual series of characters they want to print out instead of a placeholder for some number. So in order to print out a word, we have to encapsulate the word or the series of letters with quotation marks. So very simple. I have to surround my series of letters with quotation marks. And now if I run the code, it prints out just fine. Beautiful. Now this series of letters between quotation marks is known as a type of data called a string. Now when we were passing numbers in Python, such as print 2010, this type of data, or data type, is called an int. An int is just any positive or negative whole number, and a string is just a series of characters, of course enclosed in quotation marks. Now there are many data types that we'll be using in Python, but for today we'll just be working with strings and ints. Pretty simple. Strings are just series of characters and ints are numbers. Cool. Now as I said, in the Python shell window, it is in this window that we can have the output of our code show up. However, a cool tool of the Python IDE, or idle, is I can actually run short segments of code directly in the Python shell. So in the exact same way I had print 2010 or 2020 in my program window, I can have that exact same line of code in my Python shell. Print 2020, and it's going to have the same output, which was 2020. See, it's the same. So this is a really useful tool if you want to quickly test out segments of code. So for example, what happens if I type print 2020 but then plus 2010? What's going to happen then? Do you guys know? Well, we can know just by pressing the enter button. So Python actually does the math, and it takes the sum of the two values, right? We can also make variables, so I can initialize a variable num, let's say, to be 2010, or then I can print that out, print num, and then I can change the same variable, so I can now make num equal to num plus, let's say, 50. So here I'm saying that I want num to be equal to the previous value of num plus 50. And I can print that out, whatever that is. As you can see, the value of num has changed accordingly. And of course, we can do our testing with strings. So print, let's say hello. It's going to have the exact same output. Now what happens if I type print and then two strings, string 1 and string 2, and I have these two strings concatenated with a plus sign? What's going to happen then? Any idea? Can you take a guess? However, in order to test our code, we just run it. And Python will connect these two strings together with the plus sign, or concatenate. So pretty simple. I have a question for you. Proposition. How exactly can we go about printing both a string and a number in the same print function? How do we go about doing that? Any ideas? Well, fortunately, you can try this out quite easily. So I can type print, and then I can type my string. Let's say it's hello, and let's say I wanted to type a number in this print function as well. Let's say I wanted to say hello 2020, hello to this year 2020. Now, will this code work? Will that print out hello 2020? What do you guys think? Well, I can just run the code to make it work, or to see what happens. So Python threw me an error. It's saying that I can't print this out because Python is trying to concatenate or connect these two pieces of data, but these pieces of data are different types. One is a string and one is an int, and Python cannot connect them. So is it then impossible to print out hello 2020? Well, not exactly. There is a way. And you guys can stop the video right here to try to figure out how to print hello 2020. Play around with the idle, try to figure it out. But if you've given up or don't know or don't care, the way we can print both a string and a number in the same line is to type print, once again the print function, and then in terms of the value we're passing in, well, the first value can be a string, and then I can put my number, 2020, and the two are separated with a comma. And with a comma, we can now print both a string and then subsequently an integer. Beautiful. Oh, but I guess it automatically adds a space between the two. So there's no need then to have the space that I put right here, because Python will automatically add a space with the comma. Beautiful. Right? But then if I try to print hello plus world, and I didn't have a space, Python's not going to add a space with the plus sign. But if I write the same code, but just change this to a comma, what happens then? Then Python will replace the comma with a space, or a space character. So what I really recommend and ask you to do is to pause this video and play around in idle. Play around with the print function and try printing out cool, zany new things. That is the real way you're going to learn how to code, not by me just talking about code and you watching me code on a screen, but really you're going to learn how to code just by playing around with the functions and seeing how things work. And if this is way if this is way too simple for where you are because you have a lot of previous coding experience, I do apologize. But try to do something a bit more zany or a bit more wacky or a bit more fun. In the few minutes you can pause to do something cool and smart and nifty with the print function. So you guys can pause and try that out. At this point, we definitely know how to print out data or output data in Python with the print function, of course. But how do we input data? How do we allow a user to actually enter in custom values into our program? Well, we can input data with the input statement. If I just write input, followed by 2 brackets to signify the input function, if I run this code, and I could run my code by hitting run module, or by hitting F5 on my keyboard, well, this program that I've just made is not going to finish executing. We're not going to get these 3 arrow signs to signify the end of the program until we enter something in. And now the program is finished after the input has been received. However, the user is not going to really understand what to enter in unless they have some sort of written prompt. Fortunately, the input function has this exact capability. The first parameter of the function is a string. And whatever string I type in, let's say it's enter in a word, well, that exact same string is going to show up in my prompt. And now I know what to do. It's asking me to enter in a word. I'm going to enter in a word. Let's say the word is lasagna. Beautiful. Now, how can we actually store the data that the user is entering in? Any ideas? We can use the variable, of course. Yeah, the variable system. So I can initialize a new variable, let's call it word, and I can make that equal to my input. Now, whatever my input is will be equal to word, and I can verify this with a print statement. So I can now print out my word variable, and that should be equal to whatever the input was. I can write this out to be a bit more clear. The word you entered is, and then I'll add a plus here, and that's perfect. And now if I run this code, well, it's asking me to enter in a word, and whatever that word is, in this case it's donkey, that value is going to be equal to the word variable. And I can verify this because in the next line of code that we're going to run, the print statement, it says the word you entered is word variable, which is donkey. Easy peasy. And of course, I don't just have to enter in a string, I can also enter in a number, an int. So I can change this up just a bit to make it a bit more sense logically. So enter in not a word, but I can change the prompt to number, and I can make that equal to the new num variable. I can change this to a comma, And this is the same code, essentially, but I can have this work for a number. Oh, I should probably change the variable name to be correct. That matters. And now if I run this code, it's going to ask me to enter in a number. I'll enter in a number, and my code works the exact same way. Very simple. And this seems to work. And I'm saying seems with quotation marks. But this is so simple that let's do a little challenge. Let's try to make a calculator. So the goal of this challenge is we're going to write a program that prompts the user to enter in a number, and then it prompts the user to enter in another number. So we're going to have two input statements, and we're going to output the sum of those two numbers. Very simple. Okay, so take 2 minutes and try that out. Pause the video, try it out. Okay, now I'm going to take a crack at it too. I'm not as smart as you guys, so it's going to take me a bit longer. My apologies, I'm talking all day. Okay, so in the code, I have to enter in two numbers. I'll enter in my first number, I'll call that num1. Enter in a number, makes sense, my prompt makes sense. Then I can have the exact same input statement again, but this time for a second variable. Then I have to sum the two values together, so I can make a third variable called, well, I can't call it sum, because sum is a predefined function, and we shouldn't name our functions the same name as a predefined function. You know it's a built-in function because it's purple, so input is also a built-in function, print is also a built-in function. So instead, a better name is total, and I can make total equal to num1 plus num2. And then I can print out whatever the total is. So I can say the total is, and then I can write the variable, which is total. And should these two be separated with a plus or comma? Comma, okay. So is this going to work? Interesting. Okay, let's try it out. Let's see what happens. Okay, so I have my first prompt, that works. Enter in a number. I'm going to enter in 25. Enter in a number again, this is num2. I'll enter in 10. And what should the output be? 25 plus 10? Oh, that's some tough maths. I can't do any quick maths. Okay, let's try this out. So the output, I think it should be 35. And what do we get? We get not 35. Okay, so why did this happen? Well, it seems that Python did not add these two as ints. It added them up as strings. Because of course, whether I type a number or some letters, it all just seems like characters to Python. Fortunately, we can explicitly tell Python what the input should be. And I can do something called a cast. I can cast the input to be of a specific type. If I want to make it of the int type, int is int, remember, int type, all I have to do is put this entire input function inside of an int function. And so what this does is it takes whatever input is given and it converts it to an int. I can do the same thing here. And now I can run the code again. Okay, and I can enter in my two numbers, 25, 10, and now it gives out the correct total. I have to remember to that the comma adds a space. And of course, in the exact same way that you can cast something as an int, you can also cast something as a string, and as other types that we'll be talking about later on in the course. Okay, not too bad, not too bad. So we definitely know how to output data, print function. We know how to input data, input function. But how can we add logic to our program? How can we only input or output data if a certain prerequisite condition is met? Well, we can use something called an if statement. Now, how an if statement looks like is an if statement has the following syntax. I write the letters if, that's the keyword in Python. You know it's a keyword because it's orange. So I can write if, and then I can write some condition. Like let's say I want to say that the total variable is equal to 55. If I want to say the total is equal to 55, I put 2 equals sign and then 55. And so what this line of code is saying, it's saying if total is equal to 55, and then colon to signify the end of the if statement. If that is true, then we're going to write some more code. Print the total is 55. So this is called the if statement, and how it works is if the condition up here, if this condition is true, then the code directly beneath the if statement will be executed. And when I say directly beneath, that is any code that is tabbed. Now an important thing to remember about the if statement is that the first line of the if statement has to always be finished with a colon. That signifies the end of the if statement. And then of course any lines of code that you want to be within that if statement, that you want to be executed if that if statement is true, has to be tabbed. You can have multiple lines, so I can say print, just add another if statement, yes, the total is 55. And now if I run this code, and let's say I enter in 2 values, 50 and 5. The total is going to be 55 then, which means our if statement is true, which means that any lines of code that are tabbed beneath the if statement will be executed. And I can verify this. Voila. So we had the same print statement here execute, and we had these 2 print statements that were under the if statement execute. Now, if this if statement is not true, if this condition total is equal to 55, if that is not true, then those lines of code will not execute. Like if my first number is 55 and my second number is 1, the total is going to be 56. So this if statement is not going to be true, which means that only that these lines of code that are directly beneath the if statement and tabbed will not execute. Now the if statement also has another handy tool called the else statement. And essentially, if the if statement is not true, then whatever code is within the else statement will be executed. Print the total, don't forget your quotation marks, the total is not 55. And I'll move this print statement down below. Here. Okay. Okay, so now when I execute this code, I have the if statement and the else statement. If the if statement is true, then this code will be executed. If the if statement is not true, then this code will be executed. Regardless of if it's true or not, this line is going to run because it's not tabbed below either. Okay, so let's say my input is 55 for num1 and 2 for num2. Then what's going to happen? Well, the total is going to be 57. So if total is equal to 57, 57 is not equal to 55. So this statement is false. This is not going to happen, which means that this code will run instead. So the output's going to be the total is not 55, the total is 57. Voila. And I can run this code again and verify the other case. Let's say my input is 50 and 5. Then the output is going to be this line, not this line, but also this line. Boom. Okay. Very, very simple. We got this. Easy. You guys are coding experts already. Now the last thing I want to talk about in this segment is about libraries. So the input function, the print function, these are all built-in functions in Python. they come by default with every Python program you make. Now Python, and also other stuff, has tons of other libraries of functions that you can use. But they don't come by default in your program because that would really slow your program down. Fortunately, you can import that code in. So to import a library in, I just have to use an import statement. So for this example, we're going to use the random library. So the random library is a library with tons of functions that are very cool and useful. And they're generally related to randomness. Shocking, I know. So to import the random library, I just write import random, and now I can call upon every single function in the random library. So to call upon a specific function in the random library, I can just write the library name. So if I want to call upon a function in a library, I first write the library or module name, and then I write a period, and then Python is so smart that it's going to pull up all of the functions in that library. The function that we want to use is called randint, and what this function does is it generates a random integer. And of course, I can make this function equal to, I can store the value of this function, the result of this function, by using a variable. So I can make the variable, let's say, random underscore num, and I can set it equal to this random number. Okay. And then I can print out what that random number is. The random number is random underscore num. And then I can run this code. And I can enter in my two values. Oh, my apologies. But of course, when you make this random number, you have to define the bounds of the random integer. So the bounds is either the lowest possible value for the random number or the highest possible value for the random number. So these are the two parameters that I mistakenly forgot to enter in. And so they're two integers. So the first integer is the lower bound, let's say 50. And the second integer is the upper bound. I thought it would just generate, if there were no bounds, it would just generate a random number of any type, of any value, but I guess not. So now with these two bounds, 50 and 100, this code is going to produce a random integer between these two bounds, inclusive. Okay? And so I'm entering in my number, 55, 10, and so the total is 65, still makes sense, and the random number that was generated was 54. And then I can run this code again, and it's going to generate, well, most likely, a different number. 55, 10, so I have the exact same input, but a different number was generated. Very, very useful. So the random library, and specifically the randint function, is an extremely useful function. Now, in the previous if statement that we made, we did an equal to comparison. We asked if the variable, I think it was called total, is equal to the value 55. And the equal to operator, as we talked about, is $2=. That is not the only comparison operator that you can use in your if statement or other structured program flow. There are many types of comparison operators that you can use. There's of course the equal to sign, but of course you can also use greater than, less than comparison, greater than equal to, less than equal to, or not equal to. I'm going to very quickly demonstrate these comparison operators in the Python shell. I'm using the Python shell because that's a quicker way to run code, lines of code. So $2=, that means equal to. So 55 equal to 55, that's going to be true. 55 equal to 45, the output is going to be false. However, 55 greater than 45, the output's going to be true. Now 55 greater than 55, the output for this comparison is going to be, the evaluation is going to be false. I can make it true by typing 55 is greater than or equal to 55. And now it's true. And the last comparison I can do is the not equals to sign. So I can say 55 is not equal to 35, and the output is going to be true. Now, in our if statements, we can also use some keywords to do comparison, like not, in, is, but we'll talk more about these keywords later on. For now, you can accomplish all your tasks using just equal to, not equal to, greater than, less than, greater than equal to, less than equal to. Beautiful. Now we know so much code that we can do another coding challenge. In this coding challenge, we have 3 subtasks for the program that we're designing. We're going to make a game. Now in this game, the first thing that has to be done is we have to generate a random number between 1 and 100. The next thing that our program has to do is it has to prompt the user to input a guess for that number. So we're going to ask the user through the program to guess the number as an integer. And the final thing the program has to do is it has to tell the user if their guess is too high, too low, or correct. So take a few minutes and try to code this question. I'm very confident that you can do it. Okay, let's try it out. Now, I'm not as smart as you guys, so I have to go a lot slower when coding this question. Okay, so step 1 was to import a random number. Sorry, step 1 was to generate a random number. My apologies. But to make a random number, I need to use the random library. And the random library does not come by default in Python. I have to import it, so I have to write import random. And now I can call upon the randint function in the random library. So I can say random.randint between what bounds? 1 and 100. So this line of code is going to generate a random number between 1 and 100. And I can make this all equal to a variable. Let's say random underscore number. That's step 1 and just 2 lines of code. Step 2, user input. So I'm going to say the variable guess is equal to the input. And I'm going to prompt the user to enter a guess for a number between 1 and 100. And the input is going to be a number. So what should we do to the input? We should cast it as an int. Okay, so that's step 2. We got our number and it's of the correct type. And step 3 is we need to determine if the guess is equal to the random number, if it's greater than the random number, or less than the random number. So, of course, to do this comparison, we need to make an if-else tree, an if-else structure. So I can say if guess is equal to random underscore number, I'm going to print out correct. Now, what you could do is you can make an else statement, and inside of that else statement, you can have another if statement saying if guess is greater than random number, so if the guess is greater than random number, print too high. Else, and of course, so we have 3 options, one of which is correct, the other is that the guess is too high, then of course you know that the only other possibility is that the number is too low. So this is a totally legitimate way to write this program. Perhaps an easier way is to use something called the else if statement. So the else if statement is just another if statement that only runs if the previous if statement was false. But unlike an else statement, we can add a condition. So I can say, so keep in mind that the previous code we wrote is totally okay, but I don't really like how this looks, so I'm going to use something called an else if statement instead. And I'll keep this code here, but I'll put it inside of a comment. A comment or doc string is just 3 quotes. And I'll write the code again in this new structure. Okay. And now I'll add the else if statement. And the else if statement is like an else statement, but you can also do a comparison. Else just means run this code if the previous if statement is false. Else if means run this code if the previous if statement is false. And this new condition that I can add is also true. So what's our new condition going to be? Well, I can say else if the guess is greater than random underscore number, print too high, and then so if I know that the number is either correct, too high, the only other option is that it's too low. I could also write a second else if statement, but that's not good code because we don't need to do that comparison. We're wasting time. Oh, I should probably print out what the random number is too, by the way. So print the random the random number is okay. Let's run this code. Okay, so enter a guess for a number between 1 and 100. I'm going to guess 45. Okay, so the random number that we generated was 95. My guess was 45, so of course the output was too low. And I can run my code again. Okay, enter a guess for a number between 1 and 100. Okay, let's put 99. So this time the random number that was generated was 4. My guess was 99, so the output is too high. Easy peasy, lemon squeezy. In fact, this is so easy, let's make this code a bit harder. So let's go back to what the question was, but this time we've added a 4th condition. We want our code to repeat, our game to keep going until the user correctly guesses the number. So think about this for 2 minutes. How can you get this done? So pause the video, think about it. Got it? Okay, let's now do it together. So we can make this code repeat until the user gets the correct answer. We can make it loop using something called a while loop. So the syntax for a while loop is very similar to the if statement. How the while loop works is I write while and then some condition. Let's say, so in this case, and under what condition should the game repeat? Under what condition should this game not finish running? So I'm going to give you guys some more time to think about this. Under what condition should this game keep on looping over and over? Right, so the game should only end when the guess is equal to the random number. So I'm going to say while guess is not equal to random number, we're going to repeat some code. So I'm going to move the guess above the while statement, my apologies. And I'm going to say while guess is not equal to random, and then I'm going to have an if statement. Let me just delete this, my apologies. And then we're going to have an if statement saying if guess is greater than random, print too high. And then if the guess is not greater than random and not equal to random, it must be less than the random, so I'm going to print too low. And so this code is going to repeat until the guess is correct. So we have to give the user another chance to guess the value. So I'm going to copy this guess line down here. And so the user initially guesses up here. The while loop checks to see if the guess is correct. If it's not correct, we're going to loop. We're going to keep on asking over and over and over again until we get the right value. And then if we get the right value, then this code will stop executing. We'll move past this segment, this tabbed code. And what should be the output then? So we printed out too high if it's too high, too low if it's too low. What should we print out if it's correct? We print correct. Cool. Okay, let's run this code. Is this going to work? So enter a guess for a number between 1 and 100. So, of course, at this time the random number is not told. You have to guess what it is. So I'm going to guess initially 45. And oh, my apologies. Oh, I'm sorry. So our variable name is not random, it's random number. My apologies about that, sorry. I wrote the library name. I'm sorry about the mistake. Okay, so the variable name should be random number. That's embarrassing. Okay, I'm going to run this code again. Okay, so enter a guess for a number between 1 and 100. Okay, so my guess is going to be 45, and that's too low. So if the number is too low, what should we guess then instead? If 45 is too low. Okay, let's try 65. Still too low. Okay, let's try 90. Okay, it's too high. So it must be between 90 and 65 then, according to the logic we have here. So what's happening is we're stuck in this while loop. This while loop will only break, will only stop looping between this tabbed code when guess is not equal to random number. And based off the if statements, we know that the number is greater than 65 but less than 90. So then of course we should bisect between these two numbers. Okay, so 85 is still too high. Okay, let's try 75. 75 is too low, let's try 80. 80 is too high, okay, let's try 77. 77 is too low, wow, it's taking a long time. Okay, let's try 79. Correct, okay, so the randomly guessed number is 79. Once again, my apologies for the mistake back here. I didn't write the right variable name. Writing the right variable name matters. The computer's not that smart. Cool. Okay, not too bad. I'm sure you guys are much smarter than me to make that silly mistake with the variable name. Okay, in fact, this code is so, this question was so simple to do. Let's make it a bit tougher. So in our final iteration of this question, what we want to do is we want to put this entire game inside of a user-defined function. So as I talked about before, there are some built-in functions that we can use in Python, like input, or some functions from imported libraries like random randint, but we can actually make our own function in Python, and it's fairly simple to do. Now, in the style that I'm showing you right now, it's not the best syntax in terms of making a function, but I just want to show you the method to make the function. But you shouldn't always make a function in this way, and we'll see why later on when we learn about more coding techniques. But the goal of this lesson is just to show you the syntax to make a function. So in order to make a user-defined function, I have to first write def followed by the function name. So let's name our function guessing game. And then followed by two brackets, and that's where the parameters are placed. If you don't know what parameters are, that's okay. We'll talk more about it later. And then just like with the if statements and while loops, all of the code within the guessing game function, within our user-defined function, has to be tabbed. And now we've made a function. We've moved all of our code inside of this function called guessing game. Now, how do we call a function in Python? How do I run guessing game? How do I get this function to be executed? Well, how do I call any function? I write its name, followed by 2 brackets. Like when I want to run the print function, I write print, followed by 2 brackets, and then I pass any parameters inside. With guessing game, we have no defined parameters. So if I just write guessing game, and it is case sensitive, so don't mess that up, this will call our function. And I can run our code again, and it should work the exact same way. So as you can see, enter a guess for a number between 1 and 100. Okay, let's do 45. Oh, that's funny. Okay, let's run this again. Okay. So enter a guess for a number between 1 and 100. Let's do 45. Okay, that's too low. Okay, let's do 70. That's still too low. Okay, let's do 90. Okay, that's too high. Let's do 80. That's too high. Okay, let's do 75. That's too high. My apologies, I'm going too fast. This lesson's going a bit long. Okay, so 75 is too high. 70 was too low. Okay, let's try 72. Okay, correct. So the number that was randomly generated was 72, and we guessed that after quite a few iterations. Not too shabby, not too shabby. Awesome. So already in less than an hour, or maybe a bit more than an hour, my apologies, you guys have learned how to input-output data in Python, how to make variables in Python, how to make if statements, while loops, and user-defined functions. Not too bad. In terms of next steps, all I can highly recommend is to get comfortable playing around with Python. Have fun making programs that use while loops and if statements and else statements and while loops inside if statements and else statements. Just poke around and try new things. That's really the best way you're going to learn how to code. Just by pursuing your personal side projects, not by reading a textbook or listening to some person talk on YouTube, in my opinion. Now, assignment 1 should be up on JupyterHub, and you can take a look at it. It needs to be finished by next Sunday. It's fairly easy, so I imagine you people won't have too many problems. Now, the next tutorial on Wednesday is actually pretty short on content. We're really just going to reiterate and review all the things we talked about today in some more coding problems. So because it's so short, I will also, in addition, go over how to access JupyterHub and set up the VPN on Wednesday, if that's something you guys want or need help with. I imagine it might not be so intuitive for everyone, and so if that's something you may need help with, don't worry, on Wednesday I'll talk about that too. Until then, take care, stay safe, and I hope you enjoyed today's lesson. Bye!